Hello, everybody. Good morning, good evening, wherever you are in the world, and thanks for joining us. We will be covering Gemini Multimodal RAG applications with LangChain. Hopefully, you'll enjoy this session. We're going to be very short on trying to initially understand what LangChain is, the project. We'll cover the brief agenda. But for now, my name is Crispin Velez. I am the Vertex AI lead for Google Cloud. And with me is Leonid and Aditya, if you folks want to introduce yourselves.
Sure. Hi, everybody. I'm Leonid Kulegin, based in Munich, Germany, AI engineer at Google Cloud, and I'm overseeing part of our integrations on LangChain at Vertex AI.
Hello, folks. My name is Aditya Rane. I am based out of Pune in India. I am an AI consultant at Google. Very excited to have you all in this session. Back to you, Crispin.
Thanks, folks. And please do let us know where you're joining from in the comments. It's always great to see how many folks and where are developers joining to actually join these sessions. Hopefully, this will be very valuable for you and you'll be able to learn something new today. So, with that, our agenda for today is we've got 5 topics. We're going to start with what the LangChain project is. We'll move on to Google and LangChain. What have we been doing in the LangChain space and how Google is actually integrating to this very important open source generative AI or LLM based library. And we will move into 2 different demos. One where you're going to be taking a look at LangChain basics and then multimodal RAG with Gemini. And we will close out if you are a developer and want to contribute, how you can actually pitch into the project. With that, let's start it off. So some of you might already know what LangChain is, but hopefully this is the first time you're seeing this and you'll be motivated to actually participate and collaborate. So what is LangChain? It's actually a very important, very popular library where you're going to be using an open source modular framework to actually build your applications that are powered by LLMs. So the cool thing about LangChain is you'll be able to leverage not only Gemini, but across the board, all of the or most of the most popular LLMs out there. You'll be able to build chatbots, virtual assistants. You'll be able to run through text generation, summarization, Q&A. You're gonna literally have a tool that is very flexible to build your application. It obviously relies on LLMs to go through the reasoning process. It can connect to different language models and different types of context, so prompts or contextual content, as well as combining a lot of additional components and tools. From large language models, as we mentioned, you'll be able to build agents, create memory stores, and a lot of very interesting plugins and components to create very complex workflows and applications. So what are these libraries and what are their advantages? You can see that LangChain is basically broken up into multiple components, both chains, components, and uh, um, I forgot the last one. The core components that you can take a look at are components and chains. Within components, these are basically composable tools and integrations that can work with different language models. Those components are very modular, very easy to use. And then the chains are basically elements or objects that you can put together that can help you put together all of the different modules that you're working with. So you have both off the shelf as customizable chains, and these will be available to you to actually build out your applications at the end. Advantages that you have working with LangChain, it can actually increase productivity. You've got enhanced flexibility because you'll be able to adapt those workflows to your needs. It's easy to swap in, swap out those integrations and components where you need to. And it has a very simplified way to actually integrate both external files, your plugins, your APIs, or any other component that you want to integrate into your LLM and orchestrate across. It can actually scale out to build those complex and large applications as well as workflows. And some of the latest let's say, developments are mainly focused on agents and allowing LLMs to actually interact with their environments and use LLMs to decide basically what actions they should be taking next. So the different concepts that exist today within LangChain are the ones you're seeing on the screen. On the left-hand side, you've got chains, agents, memory, and then on the right-hand side, you're seeing models, prompts, and indexes. A lot of these will actually already exist in and by themselves, but the power that actually LangChain brings is that these modules can be combined to create those more complex applications and those complex, let's say, workflows, so you can build your applications from the ground up. Some of the core components, models, prompts, memory, indexes, chains, and agents. With LLMs yet, well, there's clearly Gemini Model, the Palm family of models that we've released recently. You've got the OpenAI models, you've got Anthropic, you've got Llama, and all of the open source versions of models that are coming out are promptly being supported by LangChain. With regards to prompts, it refers to the input that you're basically feeding into the model. That's basically built from the different components that LangChain can actually provide as an interface, and it can easily work with your prompts, right? You can generate prompt templates. You can build example selectors and output parsers, depending on the use case and the specific workflow that you're working with. Memory, very important when you're building chatbots, right? You can have short-term or long-term memory. And the idea of the memory store is that when you're running through conversations, the chatbot can actually understand the context and understand the history of what you're running through within that conversation. Indexes, very important. When you're working with documents, it's actually a way to structure these, right? So LangChain can actually provide both document loaders, so you can upload those documents, you can split those documents into smaller chunks, and then vector store, so you can store the embeddings and the retrievers to actually fetch those relevant documents. Now, again, keep in mind, a lot of vendors have their own versions. Within Google Cloud, we have our own stack that is actually supported within the LangChain project as well. And chains, probably one of the most important components. This is what helps you combine those modular components or other chains in specific order to actually complete a task or build your application end to end. And last but not least, agents, I called those out previously, that they're a very powerful construct to actually integrate with other systems beyond your GenAI application through tools, and they can basically observe and start taking a look at how you can execute on a complete task. So one of the key things or elements that you can identify when working with LLMs is when you have a really complex task, you might want to break that task down into smaller, more detailed tasks. Agents are a great way to actually do that. Now we'll move quickly into the LangChain and Google partnership and the work that we've been doing. And obviously Leo and Aditya have been at the core of running that integration before we jump onto the demos and the notebooks, which is probably why most of you are here. So these integrations that we've built are across a lot of Google Cloud's products that are GenAI based. So Vertex AI and Chat Vertex AI, the text generation and chat models have been integrated into LangChain. Vertex AI Model Garden, OSS models on Vertex Model Garden have also been integrated. Vertex embeddings or Vertex AI search, Vertex AI vector search has been integrated, as well as Vertex AI search and conversation. So a lot of the products that today exist within Google Cloud as a GenAI platform or part of the GenAI platform have been integrated and have been included within this LangChain integration. This is a very brief example of how you could use Vertex AI Palm API for text. I didn't include one for Gemini because that will be what Leonid and Aditya are presenting. But the basics on this is the API actually enables you to structure your prompts, just simply adding the contextual information, basic instructions, examples, other types of text content. And it's very useful if you want to run multiple tasks like Q&A, classification or summarization, or entity extraction. And you can see on the code on the right side, it's very, very easy to basically call upon the library and the function if you want to leverage it. When it comes to the Palm API for chat, it's a very specialized model tailored for chatbot and development. It actually allows you to provide similar structured prompting to the text API. So very similar to what you saw previously, but in this case, you're going to be able, to leverage that memory store that you're using to understand the previous conversation or the history of the of the conversation, so you can move forward, right? So you'll be able to provide that contextual information, the different instructions depending on the response format, tone, level of detail, and you can structure that conversational flow that you like to have, that you'd like to expose to your users to actually interact with the LLMs. Other types of text content can actually be included. So keywords, domain-specific terms, and brand voice references can also be embedded. Embeddings, very important today and age. So when you're working with indexing, one of the key steps when you're building your retrieval augmented generative architecture is that you create embeddings out of the chunks of the documents. And with Vertex AI embeddings, you can definitely do that. And you can see here that specific service has been integrated into the LangChain libraries in a very seamless way, right? So it can accept documents with or text with up to 3072 tokens, and it can actually generate 768 dimensional text embeddings, right? So it's a floating point vector. The text embedding can actually be added to any vector store. So if you're using ChromaDB, or if you're using Pinecone, or even Google Cloud's own vector store, you can definitely leverage this component within LangChain as well. So last but not least, Vertex AI Vector Search, probably one of the core products and services today within the platform. It's a fully managed vector store that resides within Google Cloud. It can actually enable very fast search against those embeddings that you created from the documents. Today, search actually does the chunking and the embeddings internally, let's say under the hood. And it can actually help you find the most similar vectors from over 1 billion vectors. Unlike other vector stores, right, that kind of run locally, what you basically leverage with vector search is optimized for scale, multi-billion and multi-million vectors. This is enterprise-ready vector store. And you can see how that vector store is basically leveraged here. So quick correction on what I mentioned previously. This is the Vertex AI vector search. So what you're running here is just the vector search against the embeddings. So when you're building the end-to-end RAG, or when you're building that RAG from the ground up, that means splitting your documents, creating embeddings from those chunks, and then re-ranking or searching those specific embeddings, you'd be using Vertex AI vector search. This is a high-level agnostic, if you will, architecture of what a RAG architecture would look like. For sure, you've seen a lot of these. This can actually be leveraged with both Text Bison or Gemini Text. And the idea is that you can, with LangChain, you can actually use document loaders for CSV, file directories, markdowns, HTML, JSON, PDFs, whatever text format you're basically working with. And what you're seeing below is basically using the Python PDF loader. As I mentioned previously, your documents, you're splitting. Those chunks are basically then transformed via embeddings. You build your index within that vector store, and then the interaction between the user is via query, where the query is embedded. The semantic search is run across the vector store and the index that was built. And then the response is sent out to what we call a generation stage, which is the LLM that provides the answer. Pretty straightforward. Now, when we talk about Gemini, you've heard that we've built in, or the architecture that Gemini currently has is a multimodal architecture, right? Or we call it a multimodal large language model. In that sense, what changes is that you can now feed any type of, or you can feed certain types of modalities, of data modality. That means that you can feed in audio, you can feed in video, you can feed in images. And the core differentiation between a sole text, if you want, retriever to a multimodal retriever is the type of encoders that you're using when it comes to generating the scoring, right? So when you're using a query across the document versus when you're using an image, right, or any other type of information, basically the mixed modal encoder starts understanding what type of information is there. It creates that specific embedding to generate the specific scoring that you're looking for. And then for the generation piece, it basically uses the transformer component to actually calculate the loss for the retriever docs and the loss for the main doc, which could include an image, as you've seen, right? So what a multi-model architecture basically does is it breaks up the type of data modality that it's basically processing, but then within the transformer, it's joining that similarity cosine score that is actually taking part. I will hand it off to Leonid to jump onto the demo.
Yes, sure. Thank you, Kristen. You probably see my notebook now. So essentially everything, not everything, but most of components on LangChain are runnables. And runnable takes an input and returns an output. And you can compose runnables into sequences. And essentially this sequence is a chain. So it's just, a sequence of a chain of runnables that takes an output of each runnable and, uses it as an input to the next runnable. And Vertex AI is also a runnable. And what LangChain is doing, it's orchestration and invokes these runnables one by one in this chain. So first, we have a separate library to make it easier to install dependencies. It's called LangChain Google Vertex AI. So you install this library and then you create the Vertex AI instance. You can use different models. For now, we will use Gemini Pro, but then we will also take a look into multimodal models. So we have created a model, and let's look how we can actually stream the response. So we create our question, and okay, live demos are always dangerous, but we get some question from the model's memory. So the factuality, as we all know, is not guaranteed. The models can hallucinate, and in order to deal with these hallucinations, Aditya will later explain how we can build our own RAG. But so far, let's look at the next step. Essentially, let's look at the very naive, very simple chain, how we chain things together. We can actually build some template. So company as a name, year also as a template. Then we use some prompt template component of LangChain. And then we chain together prompt and the model itself. You might be wondering, what does this vertical line actually means? This is a bitwise operator in Python, as some of us might remember. You might ask myself, okay, what does bitwise comparison operator has to do with this? Essentially, as I mentioned already, most of components on LangChain are runnables. So runnables override the __ or operator, and by bitwise comparison, they mean actually combining two components together, two runnables together into a runnable sequence. So another hidden kind of component of LangChain. Essentially, what's happening here when we use this syntax, and it's a very easy syntax to create your chain, we are kind of invoking this thing. And obviously, we can have a lot of stuff that way, and this will create a chain. And we can stream things out of chain, or we can actually invoke a chain. So let's see what happens. As you can see, we have substituted BMW and the correct year, and we got our response. And the kind of main thing, what you do, you invoke a chain. So that's actually what's happening here. We got our result as a string. We can also add additional parameters. For example, just a simple thing, let's add some stop sequence and, for example, change the temperature. We click, and as we can see, our response actually stopped because like we have reached this stop word in our response. So we got like a short response. One additional important things maybe to mention, if you like use additional methods, for example, like generate, you can get like the so to say full response of the model, and you get access to additional things like safety ratings or citation metadata if applicable, or for example usage metadata like amount of tokens consumed and these kind of things. If you have long chains, of course, that's not the best way of doing things. That's why LangChain has this notion of callbacks, and each component you can define your own callbacks, and these callbacks will actually collect this additional generation info for your later analysis and usage. Now let's go to additional like component that you have on LangChain, chat model. Chat model, you can have a chat, and essentially you define your messages like human message and AI message. A message has content and additional metadata, and you can provide a history of messages to get an AI message as a response from a model. Let's take a look at a very simple example. Essentially, we can do the same with a chat model by providing a human message. The key idea here is that essentially you can provide a sequence of human message, AI message, human message, AI message, and get a response. And you might ask myself, why is it relevant if we are talking about multimodal input? And the answer is, in LangChain, chat interface is the way to deal with multimodal content. And let's take a look how we can do this. Yes, you can actually stream also with the chat model, kind of same thing. But now let's go to the multi-modality. For this, we need to use a different model, Gemini Pro Vision. We just like change the model name and instantiate the chat vision model. First, let's start with a simple thing. Let's create a human message with a text content. And let's ask the model, hello, who are you? And we get an answer. I am Gemini, a multimodal AI language model developed by Google. I am designed to understand and generate human language and to assist people with a wide range of language-related tasks. To deal with the images, you can use some utilities that we have created in our library called image byte loader. I will give you an example, but essentially you don't even need it. That's why it's hidden in the underscore image utils. We'll just use it to load an image from bytes and show you actually a very cute dog. That's my dog, and let's ask what this dog actually what does the model see on this image. What we need like a text part of the message and an image part of the message. And in the image part, we actually tell that this is an image URL, and then as a type and as an image URL, we can provide a path to the local image. And then the model itself, like your local instance of the ChatVertex AI model, will upload this image and send the byte to the server and ask actually the question about this image. And we create this human message with the multiple parts within the content. So as you can see, we have a text message and an image message. I've just realized maybe my name is not the best. It should be actually text part of the message and image part of the message. But let's give it a try. Let's see what the model says. And as we can see, the image shows a dog sitting on a wooden floor. The dog is small breed with a long, shaggy coat. The dog is looking at the camera with a curious expression. That's cute. We can even make it simpler. So we don't actually need to compose this complex text message. We just can send a text. So just actually can send this question. Text message text is just our question. Let's see. We might get a little bit different result because my temperature is not 0. Yes. The image shows a dog. The dog is sitting on a wooden floor, kind of more or less the same. The dog has brown and black fur, and so on and so forth. Now I copied another image like from the Google Cloud Storage, from the bucket, but I will actually use this as a URL. Sorry, my bad. Let me do that. So what we are doing here, as you can see in the image message, I'm pointing the model to the Google Cloud Storage itself. So we can actually ask the model questions about Google Cloud Storage. I also copied this message to my Colab instance just to display it here. So I'm only using the local copy to display it. And I asked the model describe the scene. So the prompt, and then the second part is the image message. And we can see the model described the scene more or less correctly. Two pontoon boats are anchored in the Charles River in Boston, Massachusetts. In the background are some bridge and so on and so forth. Let's actually ask a question about the image that is a web link. So again, same thing. I just provide the same URL. So essentially, in our utility class, we use a simple heuristics to actually detect what type of URL you have provided. Same thing here. So the image shows the New York Stock Exchange trading floor. Correct. This is one person in the floor, a man in a suit who is walking towards the camera. He's surrounded by electronic screens. So I actually feel like the model is doing a pretty good job. This is the image itself. Last but not least, what if actually you want to have some kind of few shot experience with the model? You can actually provide few parts of the message. For example, in this case, let's imagine we want to get these JSONs like city, landmark, and some description. And we have three URLs, 2 examples, and then what we will get back. So let's see. That was our first example, example of what to expect, example of the image. Second example, Paris, landmark, some description. And that's what we got from the model. Rome, Colosseum, positive historical event, the unification of Italy. Okay. Now, the last example, until I hand it over to Aditya, let's ask example about some financial graphs. And what do we see here? We actually see first the Google stock, industry, tech, description, price up in the past six months. It is trading at specific price and so on and so forth. Let's scroll down, actually look at the model response for the specific image. I probably should make it a little bit smaller. So yes, and this is the question about the Amazon, the last one. No, sorry, about Meta. The model was able to detect the ticker, the industry, and actually provided a pretty good description. Meta platform stock price is down in the past 1 month. It's trading at this price with an increase in the after hours. The stock price has fallen compared to November 2023. And thanks for your attention. Aditya, I'm handing it back to you.
Thanks, Leo. Thanks, Crispin. So now to the most awaited part of the demo. So far what we've seen is we've seen how different aspects or different offerings of Google Cloud Vertex AI are integrated into LangChain. Leo actually walked you through how those individual parts work one by one. Now we actually try to put all these parts together and come up with a meaningful use case. And I think in the past 12 months or so, retrieval augmented generation has been one of the most widely used techniques, and it has been implemented and used widely in the field of LLMs. So that's what we are going to do in today's demo as well. So for those who are kind of sort of new to this, retrieval augmented generation is a way to actually ground the model's responses, which means that the model is given a certain context and the model tries to answer based on that certain context. So it does not use its own parametric memory, and that prevents it from hallucinating. Now, those who might have tried different variations of this retrieval augmented generation might have felt that, okay, it works very well with data, it text data specifically, because you have very mature technology to deal with text data. You have very mature technology to embed the text data and retrieve the text data. But what if your data in the real world is slightly more complex? So that's what we are going to look at. So we'll start with the what, which means what are we trying to do, and then I'll switch to how we are going to do. So this is one of the PDFs, or this is an example of a PDF, which has text inside it, but it also has tables. It also has tables which are embedded inside the PDF as images, and it also has a bunch of charts in it. So typically, those who have worked extensively with text data yet will soon realize that all of these kind of data, the images, the charts, a text-based model or a text-based embedding model will not be able to typically capture all these nuances. So that is where the power of multimodality comes into picture. And what we saw is Vertex AI offers you a few models in the multimodal space. So you have Gemini Pro Vision, you have Gemini Pro on the text side, you have the Bison models on the text side. So combining the power of all of these models, you can build a multimodal retrieval augmented generation. So what we are going to try and do in this demo is we're going to take this PDF, we're going to ask it a question, and we are going to try and get the answer. So like I said, I always start with the what. For example, I'm going to ask it a question: what are the enterprise value with the next 12 months of revenue, and what is the percentage revenue growth for Adobe? And the model is going to give me an answer. Probably, hopefully, this is the right answer. So it is 12.3x and 12%. So the answer is probably coming from this part of the table. I'll zoom in a bit for everybody's benefit. So what the model is doing is it is querying this particular part of the document, and it is giving out these two numbers to you. So 12.3x and 12%. Now, this is the what part. And now, obviously, as engineers, you are curious on how I was able to, get to this part of it. So we'll look at the code one by one. So this notebook is available, and we'll link it in the comments for you guys to refer. What we are going to do is I'm going to download this set of PDF on my local collab instance, which I've already done. And as you can see, the PDF is already downloaded. I've extracted the images for a quicker demo. So these individual images are actually the images that are inside the PDF. And I'm going to try and load this with the LangChain PyPDF loader and see what the texts are. So just to double check if the text is loaded correctly, I'm going to look at the first chunk, and it talks about a date on the clouded judgment and something like that. So ideally, it should be taking this text, which is like the first page. So right now, what I've just done is I've loaded the PDF, I've extracted the text, and I've verified that the correct text is actually being extracted. We also have 21 pages in this PDF. So ideally, the number of pages that this extractor needs to load is again 21. So again, we are now confident that we are able to load the PDF correctly. We are able to read the entire text. Now let's move on to the enhancement part of it. So before we actually perform or build an index, we are going to actually read this text and give it to a model and try to generate a meaningful summary out of it. And we are also giving the model a specific personality so that it generates the summary in a specific format. So we are asking it to be an assistant who is tasked with summarizing tables and text for retrieval. And we are also telling it that we are going to embed it so that it gives the proper output. So I'm going to run it again. All the text so far, all the 21 pages are going to go and through this summarization loop. It will take a little bit of time. And ultimately, what you will get in return is a list of a summarized version of all those pages. So again, just to double check if we have gotten all of those correct, we will see how many, how many summaries has the model generated. So it will hopefully give out the number 21. So we have 21 pages. Now we also need to deal with the image part, and that was like what the earlier text only RAG systems were unable to do. So this part of the notebook is going to actually try and convert those tables or those pictures that you have into text which we can index. And for that, we are going to use the Gemini Pro Vision model. So all the individual charts within the PDF, all the figures within the PDF are going to be passed one by one to this Gemini provision model. And we are going to task it with the same personality, but this time we are going to tell it that you are looking at images and you give us what you think is going on in the image. So just like Leo explained 5 minutes back, it is able to look at an image and give you a very, very accurate description of what it thinks is going on to that image. So for example, if I run this, I'm going to get a set of images. I'm going to get a set of summaries. So again, just to save everybody's time, I've already generated it. And we have 5 images in the PDF. So we have 5 images in base 64 and we have 5 corresponding summaries. And if I just have a look at one of these images, the Gemini Pro Vision model was able to identify that the image is actually a line chart of enterprise value by the next 12 months revenue multiples over a time. It is also able to identify some of the labels on that graph. It is able to identify what is there on the axis, etc. So which means that now suddenly we are moving beyond text and we are using the visual information that is present in the PDF to actually get our answers from. So this is what we are dealing with, two modalities here. We just use the Gemini Pro model just to summarize the text and retrieve information. We also use Gemini Pro Vision model to look at all the images within the PDF and tell us what it thinks. Now, obviously, the next step is we are going to take all of this information generated so far and we are going to build a vector store. So again, vector store is like sort of the heavy lifting. So I've already built a vector store. It is in local Chroma DB, but like we mentioned that it is also important that the kind of embeddings that you choose for building your vector store ultimately decides the quality of your retrieval. So there's a very state-of-the-art embeddings model which is also provided by Vertex AI Embedding, and we have a class which helps you implement or leverage this model in LangChain. So we are going to use the text embeddings Gecko latest model. So once a retriever is actually built, you actually go ahead and build the actual RAG pipeline, which means that once you query, your query goes and looks at the vector database. It tries to retrieve the specific information. Please remember that your information is now in two formats. It is in text, it is also in image. So there is a list of helper functions which actually tries to look at what sort of data is being retrieved and tries to classify. For example, if the data is has certain amount of signature, as people who deal with base 64 might know, there are the formats that are encoded. So these are a set of helper functions that help you identify what modality of data is being retrieved. And finally, you have the image prompt function where you are actually telling the model that now I'm going to use you or I'm going to take your help for providing investment advice. Or this is like the personality of the chatbot that is going to ultimately give you the answer. So we are going to task it with being a financial analyst and providing invoice. Providing financial advice, and basically it's going to look at the text data and activate its right set of attention mechanism and give you right set of answers. So these are the helper functions. Like Leo mentioned, everything is runnable, so you run it through a chain where you pass the context. The context is coming from the retriever or the vector database that we just built, and this is the question that the user is going to ask. Finally, this is the RAG chain, and basically that is how you implement it. Now, one of the questions that we are going to ask it is what is the enterprise value by the next 12 months of revenue? And we are going to just try and check if we are getting sort of one of the documents that we actually intend to get. So, for example, this is like one of the documents. It has retrieved 4 relevant documents that it thinks are relevant. And if you look at the kind of docs it has retrieved, I'll just try to print out. Uh, yeah. So what you see is this is a list of docs. It has 4 docs, but it has retrieved a part of text, but it has also retrieved the base 64 image, which means that the context is both text as well as image. And if you plot one of these images, and this is the image of interest, and this is where our answer is going to come from, is actually the third doc. So we are going to ask it a question. We have asked it a question about the enterprise value by the next 12 months of revenue, and this chart, I will just zoom out a bit, uh, is actually giving you that kind of information. So what we've done is we've just done multimodal retrieval, which means we've asked a question, matched it up with the corresponding text, matched it up with whatever information we got from the image data, and now we've run a hybrid retrieval. So those who have done RAG pipelines or RAG implementations, you will understand that sometimes you need to provide citations, or it is always better to provide citations. And one pain point for multimodal RAG was how do we provide visual or images as citation? So this notebook again gives you the ability to actually provide an image. So when you are returning these results in a production application, you can actually return this particular image, decoded base 64 image, as a source for your answer as well. So with that, let's hopefully run our final question, which is we want the enterprise value by next 12 months of revenue for Adobe. And this is our final answer. So 12.3x and 12%. Again, let's go and check. For Adobe, it is 12.3x and 12%. So this is how we are actually retrieving multimodal information, chunking it, vectorizing it, then feeding it into a vector store, retrieving it on demand. Mind you, we are also retrieving images and text simultaneously so that the right context is being given to the model. And finally, we are implementing a question answering system using this information. So I hope this excites you. It definitely was very exciting to build this solution because a lot of customers have been asking for it. And I hope you found these 2 demos useful. With that, I'll conclude my demo and hand it back to Crispin.
Thanks, Aditya. Definitely, that is very exciting. We're very interested in hearing in the comments what other use cases you think could actually benefit from multimodal RAG and this new multimodality use cases that Gemini actually unlocks. So feel free to drop those in the comments as well. We'll be happy to follow up on another of these events once we, set them up, scale them out. So very interesting to hear your feedback as well. Um, Before we move along into the Q&A, we wanted to share with you how we can actually, or how you can actually contribute, right? So the LangChain project is set up for Google's integration is set up in LangChain dash AI backstage LangChain dash Google. So if you want to push your PRs or want to contribute, please include yourselves and your GitHub handles in that contribution, let's say thread. And then if you want to raise any PRs, any issues, we'll clearly, our Google engineers and the LangChain engineers will definitely be reviewing those PRs. Please jump in and contribute as much as you can. Raise issues, participate in discussions. This is the way we actually build out the community and get developers, excited about our project. I think before we jump onto the community event feedback and cloud events, um, should we jump into the Q&A? What do you folks think? Yes. All right. Let me take a look at some of the questions we had. I'll start from the top down. So this is one question from a tool. Gemini 1.0 Pro Vision and Vertex AI difference. Who can access Canada location access issues with Google AI Studio? So with regards to Gemini, you're going to see a rollout coming up in the next 2-3 months across multiple regions. Do keep an eye. We have multiple release, if you want, notes within our public web pages. So keep an eye out for those. We will be definitely rolling out globally as time passes by. Thank you, Atul, for that question. Jumping on to the next one, Javier Alejandro Lozano. Hello, can you share a collaboration later with these examples? Thank you. Yes, as Aditya mentioned, we will find a way to publish these documents or include these collabs in the video that's going to be uploaded, so you can download it and use it, leverage it. Definitely, we want more people using Gemini and using LangChain as well to build their applications. So we will be posting this with the YouTube video as well. Thanks, Javier, for that. The next one from Quasi Quater. Can we get the exact amount of input-output tokens accepted by TextBison? I've got errors even if it's under 32K tokens. I don't know, Aditya or Leo, if you'd like to pitch in on this one.
Not sure. If you're using like TextBison 32K, that's weird. Maybe raise a bug. So essentially, just be aware that if you have like multiple messages within the chat model, there might be a slight difference, a few additional tokens. So essentially, if you have like 30,000 tokens and you get an error, that's weird, please raise a bug. If you are pretty close to 32,000 tokens, there might be small, additional tokens added when the model actually prepares the input to be sent to the inference itself. That's why maybe the error occurs. But like without taking a look at your specific input, it's unfortunately very, very difficult to give you a specific answer.
Thanks, Theo, for that. Let's jump on to the next one. So with the image, what happens under the hood? Will LangChain base64 encoder encode the JPEG and send it that way to the model? What image format can the model actually take?
I can take this one, Crispin, maybe. Yes, essentially, we just read the binary and send it. The Gemini provision supports PNG and JPEG, and on the documentation page, you can read about like limits on size of the image and how many images you can actually send within one input and how many tokens an image consumes. So it's all in the documentation page. Please feel free to take a look.
Great. Thanks, Theo. Next one from Manish. I think I can answer this one definitely. So you saw in the demo where Leo actually feeded multiple images into the model with a specific type of prompt where it actually should be detecting the stock handler, the percentage of increase in after hours, etc. He was actually sending multiple images to the model as well. So it does support multi-image prompting. Next one, a tool again. If I want to upload different types of files like PDF, Excel, and .docx all at once, how should I use the LangChain and store it in vector database? That's a very interesting question. Leo or Aditya, would you like?
Yeah. Go for it, Leo.
Yeah, sorry. Didn't mean to steal the mic. I mean, essentially, when you store it in the vector database, it already doesn't matter because like when you add it to the database, you have already parsed it and processed it, and you have either like an image that you have parsed from the original file or maybe a chunk of a text. What you store in the vector database, you store essentially a vector that and a corresponding chunk of text, or again an image or something else. So essentially, feel free to put it into a single vector database. And for the RAG itself, at these later stages, it kind of doesn't make a difference from which source your chunk originates from. And Aditya, feel free to add if I missed anything.
Yeah, no, I think you've covered. I just want to touch base on one point is parsing the documents is the main challenge that you want to overcome. So there are many out of the box parsers for PDF. Specifically, you need to figure out a way to parse those Excels and .docx files. Once the parsing is done and the content is extracted into either the text or the images format, then the vectorization and corresponding embedding and indexing becomes very, very simple. So the one thing that you want to focus on is how you're going to parse PDF, Excels, and dockets. As far as I know, there are specific parsers for each of these file formats. Simple Google search will get you a list of all these.
So I think this is a great segue question to what you were talking about, Aditya. How was the indexing done by LangChain? I think the key question is on LangChain, right?
Yeah. Okay. Yeah. So in the demo, what we used an in-memory vector store called as ChromaDB. So it is like one of the most popular and one of the widely used data stores. Vector databases, and it's very neatly integrated into LangChain. So what we did was we extracted a bunch of text. We extracted the summary of images using Gemini provision model, and both of these modalities now are converted into text, which means that I can use the text embedding model to generate vectors. And I fed in those vectors to the ChromaDB, and that is how the indexing was done. Alternatively, you can also use multimodal embeddings, which is a way to actually generate vision language pair embeddings if your data is in that format. And once those embeddings are generated, you can also index it back into the vector store. Now, LangChain provides you integration with a lot of vector stores. So for this demo, we typically used ChromaDB because a lot of developers use it to build prototypes. But once you are into production grade applications, you can use enterprise grade vector stores such as Vertex Vector Search, Vertex AI Search, PG Vectors on PostgreSQL. All of those integrations are well maintained in the LangChain SDK.
Great. And I think another segue question for that is Vertex embeddings the multimodal version coming to LangChain?
Oh, actually, I'm happy to take this. Essentially, the answer is yes. It's already on master, so feel free to install it from GitHub and play with that. And we will release the new version somewhere, hopefully next week.
Awesome. Thanks, though. And on this one from Saba, I want to know the details about how exactly Google does chunking. Is it semantic chunk? What chunk sizes and with what overlap? So in the examples that you saw, the chunking is actually done outside of a Google product or service. It's actually using one of the LangChain components. So when it comes to selecting semantic chunk, the size, and how you're overlapping, that strategy is defined by you. Now, there is a product and service that we did mention, which is a Vertex AI search, and that does run that, let's say, chunking strategy and overlapping internally, but it's not necessarily something that we can share. All right. Let's move on to this one again from Saba. Thank you for so many questions. How is an image indexed? Does the AI pick up cognitively significant parts of the image and indexes those, or some non-semantic chunking simply chops up the image into square pieces with some overlap? Oh, great. I think this is what we've seen across the board. How does the retriever component actually work in all of the chunking strategy? I don't know, Leo and Aditya, if any one of you might want to take that one.
Yeah, essentially, I mean, maybe there are kind of two ways of indexing an image. You can either generate it with a multimodal model. Always I have always trouble with pronouncing it. You can generate a text and then you generate embedding. So you essentially take an image, ask a model to generate a text description, and then you generate an embedding based on this description. And then what you store in the vector database, you store an embedding of this text description. And when you retrieve based on your query, find the neighbor, like this vector, it occurs that it's pretty close to the embedding of your initial query. You retrieve the image and then you add it to the context of your model. Another option is essentially you use a multimodal whatever, embeddings that kind of actually also take an image as an input, that you kind of skip this part of generating the skip this part of generating the text description. Again, how the embeddings is generated itself, it's kind of what's happening inside the LLM. Probably we shouldn't go into these details. It might take another like a few hours of explaining it. But then essentially what you store in the vector database is these embeddings, multi-mode embedding that you got. And then again, if this embedding is close to the embedding of your query, then you retrieve an image and you add it to the input of the context that you sent to the model to generate an answer. Aditya, please feel free to add something.
Yeah, no, I think you covered it perfectly, Leo. All right. I'll just pull one of these up. How can you estimate cost in terms of tokens when analyzing an image? I just shared the link via the chat on our public pricing. You can definitely find it in our public websites, so you can run those costs by yourselves.
But maybe, Kristen, sorry for interruption, just kind of one quick comment. Essentially, every image has a fixed cost in terms of like tokens consumption. So it consumes a certain amount of tokens, and that then you multiply it by the price, and you get the cost, if that makes sense. So essentially, you don't need to analyze your image content yourself. It's kind of a fixed price per image, if that makes sense.
Thanks, Leo. And I left this last one, which might seem trivial, but I think it's very important, because when any customer is thinking about building a Gen AI system and moving it into production, this is what they're thinking of, right? How can I build something that scales and that is enterprise ready? So a lot of thought around how do you build an object-oriented or service-oriented type of architecture comes into play when you're thinking about scale. So you have to think about every step, that both Leo and Aditya just ran you through: the retriever, the generator, how LMs are going to support capacity, how those retrievers are going to be supported, right? When you're thinking about, again, not 1, 2, or 3 documents, but thousands of documents, how are the embeddings going to be supported, right? So ultimately, this is probably a system design question where you have to decouple each of the stages of your application or your system. That's, I think, where LangChain does provide a lot of flexibility, but ultimately the underlying services where this runs have to support that scalability. So it all comes down to thinking about that system that you're going to be building and that you're going to be pushing into production. Leo and Aditya, I don't know if you want to add anything to that.
So I think one low-hanging fruit is, if you really want to, index it and you're not keen on maintaining all of this, you can use a managed service kind of a solution. I would specifically recommend Vector Vertex AI Search, which can actually ingest a lot of PDFs on the fly. So all you have to do is like upload them onto a data store. It does the indexing all by it, and it can handle the scale as well. So you can choose the right product which has the ability to scale at the right times and scale at the right amount. So basically then your whole application scales. So but like I mentioned, there's a retrieval part, there's a generation part, and then obviously you can't uh, deploy a notebook in production. So you need some kind of UI, you need some kind of backend, and all of these comes into picture, and then quickly this question becomes a question of system design. So hope that makes sense.
All right. I think with that, we've answered almost all, if not all, of the questions that we had in the chat. We really appreciate you coming to our session. Please do keep in mind that if you want to keep joining, learning, and getting your questions answered, join goo.gl /AI-community. For feedback on this specific event, please go to GCC event feedback, and then upcoming cloud events that you might want to join. Again, Adapting Translations, March 12th, 13th, 14th. You've got the information there, and you will have access to this recording after this. Thank you very much for joining, and we will keep in touch. Hope you can contribute to the Gemini LangChain project. We really appreciate it, and enjoy. Bye, folks.